Hey, Algebra 2, are you ready for the last section finally in this unit, graphing quadratics? I know I am. Of course, you know what that means. Review and test will be coming up next week, but we'll review for an entire week before we test. Okay? All right. Basically, it's the same rules that we did. We already did this with linear equations, y equals mx plus b, our lines. Okay, and if you remember, if we had a less than or greater than sign, we used a dotted line. If we had less than or equal to or greater than or equal to, then we used a solid line, and it's no different now. Okay, if you don't mind, I'm going to start with letter B because I like graphing in vertex form the best. Okay, it's just the easiest one to graph in, right? So I'm looking and I notice it doesn't say y equals. It says less than or equal to. So at least I know I'm going to use a solid line, okay? But then there's going to be some shading, all right? Because it's not just equal to, it's also less than the graph of this parabola. So my vertex is at 2, -3. That's what I love about vertex form. It's opening up because the 2 is positive. And to get to the next couple points on my parabola, I'm going to use the fact that A is 2 to go up 2 and over 1. Remember, we can only do that once. It's just to find the next point on the left, to the left and right of our vertex. If I want a couple other points, I might put 0 in just to see what's happening. 0 minus 2 is -2, just to get an extra point. -2 squared is 4. 4 times 2 is 8, minus 3 is 5. So I might graph 0, 5. That's 2 away from the vertex. So I know 2 away from the vertex in the other direction is also 5. So I'll use my solid line and draw the parabola. That would be fantastic if this said equals. It doesn't say equals. It says less than or equal to. So we want the y coordinates that are less than the y coordinates on this graph. Okay, so listen, where am I going to shade if I want to shade the y coordinates that are less than the y coordinates on this graph? Okay. The y coordinates less than the y coordinates on this graph are underneath. It's everything underneath the parabola. Okay, including the parabola. Okay, so the answers to this inequality aren't just the y coordinates on the graph. They're the y coordinates on the graph and less than. Okay, so we have to do the shading again. Okay, we did all that. Dashed or solid, it was solid. Which way did we shade? Down. And we used plus or minus a. We went up 2 and over 1 time. And we substituted 0 for x and we got 5 for y. I just didn't show you that in case you're filling in the notes. Okay, so it's that same thing. But if you understand that, you're pretty much done. Okay, with the first part of this video. However, let's just, do the rest as well. Let's go back to standard form. Yuck, I can't see my vertex. I can at least see that it's going to go through the y-axis at 1. It's really the only thing I can see. If I put 0 in for x, I get 1. I remember the axis of symmetry is always at the opposite of b over twice a. Let's see, that would be -2 over 2 times what's a? -1. So -2 over -2. That's +1. Okay, so my axis of symmetry, what's going to cut this in half is right here at x equals 1. That's also the x coordinate of my vertex. So my vertex is going to be 1, I don't know, let's see, if I put 1 in for x, that gives me -1 plus 2 plus 1. 1 plus 1 is 2. So my vertex is at 1, 2, which makes sense since this is opening down, isn't it? There's a negative. If a is negative, My parabola is opening down. I do have to be careful. This is just greater than, not equal to. I don't want a graph that's going to show that I'm equal, right? So I am going to have to make sure this is a dotted line. Okay, a dotted line. Now I did kind of cheat there and not graph any other points. Since 0 went through 1, 2 goes through 1 as well. Okay, if you want to graph 2, 1, only because I know that x equals 1 is my axis of symmetry. So on either side of my vertex, you know, I can find those other points. Okay, so this was a dashed line. Now, shaded up or down? Oh, I'm not sure. I want the y coordinates that are bigger, the y coordinates that are greater than the y coordinates on this line. So this time, I'm still shading on the outside, right? It's above. The fact that I want to include all the y coordinates that are bigger or above the graph here, okay? So it was dotted because there was no equal to sign. I shaded above the parabola because it was bigger than. Here I shaded under the parabola because it was less than. Okay? Let's try this then. It's in intercept form. Well, when it's in intercept form, I at least know the x-intercepts are at 3 and -1. Okay? +3 and -1. The vertex is halfway between there. So 1, 2, 3, 4. I guess I'll go 2. Yeah, the vertex must be at 1 something, right? Okay, I just add those together. -1 plus 3 and cut that in half. That's 1. Okay, that's the algebraic way to find the axis of symmetry. Add P and Q, 3 and -1, and divide by 2. I just kind of eyeballed it, and I'm like, it's 1 something. 1 what? Well, I have to put 1 in for x. Okay, I know it's 1 something. When I put 1 in for x, I get 1 minus 3 is -2. 1 plus 1 is 2. 1 -4 is my vertex. Okay, not my axis of symmetry. My vertex is 1 -4. My axis of symmetry, sorry, I was 1 step ahead of you, or of myself. My axis of symmetry is x equals 1. Okay, just like here, the vertex is 1, 2. I'm sorry. The axis of symmetry is x equals 1. Okay, so I wasn't really, I don't really graph the axis of symmetry so much anymore. You know, that vertical line that just cuts the parabola in half, but I know it exists and I just graph it from there. I just find the vertex and I know which way it opens. Hey, this is greater than or equal to, so I can use a solid, a solid line to graph my parabola. Hopefully yours is a little bit nicer than mine. Okay, I can use a solid line because of the equal to. I want all the y coordinates that are bigger than the y coordinates here. So this time I'm going to shade on the inside of my parabola. Okay, because those y coordinates will be bigger than the y coordinates on the parabola. Okay. All right, so that was a solid line and we did shade up. Okay. Those are kind of the different scenarios that you'll have as you practice in your homework this week. Okay. Now, we aren't just going to graph one quadratic inequality. We're going to graph a system of them. Okay, we did that before with systems of lines, okay, and with systems with quadratics, but we basically graph 2 at a time and we see where that overlapping situation is. And then that's wherever I graphed and shaded twice, that's the answer to the system. Okay, remember that? So it's the same here with 2 parabolas. I graphed 2 quadratic inequalities, shaded And obviously you can see, here we go. Here's the shade stuff that was shaded twice. So is 3, -2 a solution to the system? No. It was a solution to, this parabola, I guess, because it's right on it, but it's not a solution to the system. 1, -3. No. 2, 3. Yay! That is a solution. 1, 6. 1, 2, 3, 4. I can't see it, but I'm going to say yes for that as well, won't we? I can tell that it's going to be in the shaded part. You do have to be careful. If I would have said somehow like maybe 2, 0, okay, I'm going to have to go with no there because it's on a dotted line. You can't be on a dash line. You could be on the board, or I could have said 1, 2. That's fine. Okay, 1, 2 is a solution. It can be on the solid line. That's part of the double shading. It can't be on a dotted line. That's part of the double shading. Okay? So we're going to look at some systems here. I kind of want you to, I graphed the parabola and the line. I want you to figure out where the double shading is. Okay? Here's my quadratic, right? It has the square. The vertex is at 3, -6. And I was supposed to shade everything less than or equal to that. Less than or equal to the parabola. So can you picture it out here? Okay. As far as the line, slope of 1/2, y-intercept of -4, it's dotted because it's just greater than. I was supposed to shade everything above the line, right? So if you have to shade twice, that's fine. Let me just do it lightly. It's hard for me to, okay, so I wanted under the parabola, but I also wanted above the line. So can you see the part that's shaded twice? Let's take maybe some, let's see. So here, above the line, but under the parabola. I'm hoping you did better than me. That's the doubly shaded area. Okay, I was above the line, greater than the line, but less than the parabola. Okay, so the part that I would be shading twice would be right here. Okay, the quadratic ended up shading down. The linear one ended up shading up. Okay, let's try one. Y is greater than or equal to this parabola that has a vertex at -3, -2, right? -3, -2. A is 1. So I got something like this. Since it's greater than or equal to, okay, since it's greater than or equal to, I'm going to shade above the y coordinates, okay? Then, let's remember these nice, fun absolute values. It has a vertex at -3, +4. Way to go. I covered everything up. It's opening down since it's negative. These are the ones that are straight, right? They don't curve. They're absolute values. I want things less than that, so I'm going to be underneath that. So because of that, I can tell that the doubly shaded region is right in here. You see it? It's a pretty little design. Okay, so you have our absolute value graph, we have our parabola, and we shaded in the correct areas, right? The absolute values vertex was at -3, +4. The quadratic's vertex was at -3, -2. See you at the next video.